This one. Shall we go ahead? Yeah, this one. Answer is D, I guess. It's pretty easy. Tan inverse x lies between minus pi by 2 to pi by 2. We know that. But reference to inverse of sine x, we know that x lies between minus 1 to 1. Right? So reference to this x minus 1 to 1, my tan inverse x will lie between minus pi by 4 to pi by 4. That we cannot ignore. This lies between minus pi by 4 to pi by 4. Sine inverse x is lying between minus pi by 2 to pi by 2. And half sine inverse x is being asked. So it is minus pi by 4 to pi by 4. And when I'll add them up, it becomes minus pi by 4, minus pi by 4 becomes minus pi by 2 to pi by 2. Clear? You may observe that you feel like at x including pi by 2, it will not work. But it is not like this. My total answer will come pi by 2. How? You put x as 1. You'll get the answer. It becomes tan inverse 1 plus half sine inverse 1. Sine inverse 1 is pi by 4, pi by 2, pi by 2, pi by 4, and this is pi by 4. You get pi by 2 as an answer, isn't it? Don't consider that pi by 2 should be in open interval. This is a mistake normally student does. Clear? Now moving to this. Will you be able to do or shall I? Option is, I think, B. I think so. B is the answer. Or A is the answer. I think A is the answer. Not B. A. Third answer is D. Fourth answer is D, I guess. Fifth answer is, I think, A and C. Not C. I think A and C. Let me just A and D. A and not C. A and D. Okay. 1 minus x square under the root is in the denominator. You can see very well. And I want the function to be even odd checking. So you know that even odd checking, you do this. F of minus x, observing it is fx and observing it as minus fx. Then only you will say that it is even or odd. So first of all, before entering into this, we'll do what? Domain of this function. The domain is what? Minus 1 to 1, right? Wrong. Wrong. The answer is this. Because it is in the denominator. This normally student does wrong. So 1 minus x square should be greater than 0, not equal to 0. This is your domain. So talking about this is domain minus 1 to 1 open interval. We know that if I talk about x square, so x square will lie definitely between 0 to 1, including 0. This is there. So when you do greatest integer of this, the answer will be 0, right? So your fx will look like, because you need to move in minus 1 to 1, fx will look like x times 0 plus 1 over square root of 1 minus x square. So this will go. So you are having only this as the answer of fx under its domain. Am I clear? And this is even function, you can very well see. Secondly, only takes the positive values, that also you can observe. Periodic is not possible, algebraic. And second is odd function, which has is even, so how can it be odd? Okay. Next. This one, I think answer is A and B. Yes, you want me to do or you have understood? Tell me. Okay. What I'll do, he is asking 0 plus and 0 minus. Okay. And telling that is continuous. If it is 0 plus 0 minus matches, then we'll say. So first of all, we'll go for 0 plus. Limit h approaches to 0. I'm calculating direct RHL. Okay. So this is cos inverse 1 minus h square direct. 0 plus h is h only in fractional part. You know very well. Sin inverse 1 minus h over h minus h cube. Is it okay? Now, we know very well on h approaching to 0, it becomes cos inverse 1 and cos inverse 1 is 0. This is the trouble I have. H approaches to 0, this becomes sin inverse 1, which is pi by 2. This is my safe. So I don't want to touch this. H approaches to 0, only h is going to trouble me. So I'll do what? Cos inverse 1 minus h square over h multiplied 1 minus h square sin inverse 1 minus h, keeping here. Okay. This is not to give me any kind of trouble. My answer from this place is h approaches to 0, sin inverse 1 pi over 2 over 1. So this is pi over 2. Keep aside. Thinking on this, which is 0 over 0 form, I need to differentiate. I need to differentiate up and down because it is LH rule applicable. So I applied LH rule, so it becomes minus cos inverse derivative minus 1 upon under root 1 minus h square whole square. Cos inverse x derivative is minus 1 upon under root of 1 minus x square. Chain rule followed. This becomes minus 2h as well. Am I clear? Limit h approaches to 0 running in this, denominator becomes 1. So when you see that, this minus becomes plus and you have 2h. Down the square root, I'll have 1 will cancel with 1. You'll have h 2h square minus h power 4. Is that clear? Take h square out. Under the root becomes h. Limit h approaches to 0 is running. So I'll have h square out becomes 2h over h 2 minus h square. Right? Limit h approaches to 0 running. H goes off. H goes from this place also. So I got the answer as 2 over root 2. And this is pi over 2. My answer is pi over 2 multiplied by 2 over root 2. 2 goes off. Pi over root 2 is the value of 0 plus. You understood? I have the 7th question. The key is A and C. A and C. Yeah, you want me to do? 8th question, the key is A and C. A and C. Yeah, tell me. Okay, I'm doing that. So, how to do this? Simple as that. Decreases. Function is decreasing. I have to calculate f dash x, right? I'll calculate f dash x. F dash x is going to be no variable. As we did the derivative now, just now, square root 1 minus multiplied by chain rule of this. That value is minus 4x. You know this, or shall I tell you how? This is known to you. So this is forming my f dash x, which should be decreasing. I have, this is gone, 4x over x square plus 1 whole square, 1 plus x square square minus of 1 minus x square square, and down the root is 1 plus x square, which will go, right? So my whole system will be only based on, you just open this, inside this you will get only 4x square inside, isn't it? And you just further can solve with this. You have 4x over 2 mod x. You have 2x over mod x. So for positive zone, it's just like a signum function, you can see that. So it will be negative when x is less than 0, and it will be positive when x is greater than 0. It should be decreasing for less than 0, so it is going to be in this as well as in this, isn't it? So coming to 9th question. 9th, the key is ABCD all. All are correct. Shall we do or we should skip? Tell me. We'll do that. First of all, understand this is 3x square plus 12x minus 1. Naturally, it is a parabola, isn't it? And this parabola is going to be having a minus. Just plot it, sketch. It would be better. Its plotting is what? 6x plus 12. X is minus 2. So minus 2 is its vertex, right? And at minus 2, my my y value will be 3 times 4 minus 24 minus 1. 12 minus 25 minus 13. At minus 2, it is minus 13, somewhere here down. Opening upward goes like this, goes like this. This is clear? What they want me, I want the thing should be in minus 1 to 2. So minus 1 will come here and 2 will come somewhere here. I can check that also, what will happen to 2. So what will happen to 2, if I see, I'll put 2 in this, so I'll get 12 plus 24 minus 1. I'll get 35. So 2 will come somewhere here. So minus 1 to 2, the thing is increasing. You can very well see. So this is given fx is increasing in minus 1 to 2, which is automatically we can check from this place as well. Minus 1 to 2, I can check this A option from this place. greater than -2, it is increasing. One thing. Second thing is, going for B, fx is continuous in -1 to 3. So continuity to be checked in -1 to 3, it's a polynomial, it is going to be continuous. It's a polynomial continuous in this, only the point to be checked is 2. So at 2 we got the answer as 35 from the up, and we know at 2 it is also 35. So it is continuous at 2 also. Right? Two options are correct. So derivative does not exist at 2. They are saying that. So let me check the derivative directly of this. Its derivative is -1. Means at RHD of 2 is -1. And LHD of 2 is 6x plus 12. Putting 2 in this becomes 24. So LHD, L of f dash 2 is not equal to R of f dash 2, which is -1 and which is 24. That's why C is also the correct answer. Fx has maximum value at x equal to 2. So what we have to see at y at 2 is the maximum value. When it is going to switch, increase to decrease or decrease to increase, that we have to check out what will happen at that point. So at 2 it is continuous, we know very well, and it is coming increasing, and then followed by 37 minus x is going to decrease. It goes like this. So the point will come at 2, a sharp edge, which is increase to decrease shift. Hence the point will be at maximum at 2 as 35. It is exceptional case of continuity differentiability case. When the sharp edges come, we need to neighborhood check that this point is going to give me the largest most peak, increase to decrease shift, irrespective that that point is not differentiable or even then. Am I clear? Shall we proceed? So 10th question is, assume the inverse of a function f is denoted by g. Which of the statement holds good? I think this question is a property of inverse. You must have done it. 10th. Answer is A, C and D. We go with 11th now. If a function f is continuous for all x, f has a relative maxima in -1 to 4 and relative minimum in 3 to -2. Which of the following statements can be incorrect? So 11th, the key is A, B and C. Tell me, have you done it? Okay. See, this is the point given. At x equal to -1, the value is 4 and it is going to be max. This is being reached as max, let us suppose like this. And relative minimum at 3, -2. 3 is here and -2 is here. So it goes like somewhere, continuous is like this, so it is like this. Goes down. Naturally, when it is a continuous, one says maximum, another says minimum. So, and from positive value to negative value you are traveling of y. It will cross x-axis, surely. And on crossing x-axis, your concavity also changes. You will get the point of inflection. You understand the concavity? The curvature's concavity means the tangents from one place changes over to the next one. And f dash x will definitely come out to be 0 in between as well. Second, f dash -1 is equal to 0. Obviously it is correct because at -1 you are getting max. So the tangent will be, your critical point will definitely exist. Going to next, the graph of f has horizontal tangent at x equal to 3. Naturally, it will be there. This is correct. The graph will intersect both the coordinate axes. We cannot have the surety y, but that will be there surely, because it has to go from max to, or it can have this also. It will intersect both the coordinate axes. I think the D answer should also be correct. But I think so. Should be correct, because f dash 1 is relative maximum and relative minimum. They should have these points. This point should also exist. Let us make it again what they are saying. At -1, it is 4, right? And at 3, you have -2. So when you have max over here, min over here, and it is continuous also, something like this will go now. Isn't it? Will not meet directly. Point of inflection, okay, we can say that, we can think over ki may or may not be there, but f of -1, when the relative max or min is there, I would say that, you know the meaning of relative max and relative min? Tell me, do you know relative max, relative min? What is relative max? No, that is a local max, absolute min is correct. But the question is saying, what I believe is, relative max means like this. The point where the differentiability violates, but max exists. And relative min also of the same way. The differentiability does not exist, but min is there. You understand what I said? Local max, local min, absolute max, absolute min exist. That we understand. Absolute max, absolute min is the function's value at that point of local max and point of local min. Global max, global min is out of that the total one, relatively considering the endpoints as well. But when we talk about relative max, relative min, they are those values at which function's differentiability is not existing, but we write the max and min observation, which was done in the previous question. You have seen that. You have seen that previous question, this one. We did this. As maximum value at 2. But that was a relative max. That will be a relative max. You understand? So relative max stands for, on that we have only, we can say these options are incorrect. Otherwise, these options will be from the local max, local min point of view, their options are correct. So relative max, relative min will work out on this way, give you the answer. The point of inflection won't exist because they will have such kind of non-differentiable points. So the graph can be continuous, could be in curvature or could not be in curvature. We cannot have a certainty. Secondly, f-1 is equal to 0 is not sure because they are meeting at that point is not a point of critical point over there. Third thing, the graph has horizontal tangent at -3. Again, for relative max and relative mean, we will not get a horizontal tangent at this point. This is the reason why they are being incorrect, because it is relative max, relative min thing is there. And the graph will intersect both the coordinate axes, that is correct, because whether they will cut it like this, so definitely it will cut both the axes. From the left way, from where it is being coming, we don't know, but they will definitely cut at this and this point. Understood? So remember, relative max, relative mean is the non-differential points where max and min are being talked about. Shall we proceed? Point of inflection. See, in this case, somewhere between this, the graph f has a point of inflection which you are saying. The graph which is not being known to us, whether it is a smooth graph or the concavity or convexity, when relative max, relative min is being talked about, the graph could be a linear, could be a curvature, but at these points, differentiability violates 100%. Two curvatures may join two curvatures. I'll just make it and tell you how. At this point and at this point, when you move it, a joining point is there, means the graph comes like somewhere this way and then changeovers like this. You never know, it goes straight, then it goes like this. Could be possible. You never know. So point of inflection comes in that way. Certainty is not there. We cannot say may or may not. Fx has a point, it is not surely being told. Point of inflection may come in between, may not be. We cannot say concretely it will exist. That is the reason that this answer would be considered as not 100% correct. This is the reason. Shall we go ahead? This one, hopefully you might have done it. The answer is 22. Number of integral values of fx can take is, I think AMGM you can think over, or you can apply the value of sin square x and cos square x, how much they can move. I think that is the way you have to do this question. Or you want me to do? Yeah. Evaluate this. I think the key is giving me 13th. Yeah. The answer is 1. Answer is 1. G of fx is x, means, you understand? Fx and gx are inverse of each other. You need to find the inverse of this function and then you have to proceed. The answer is 1, as I told. Yes, you want me to do, or you will go ahead? 14th. The key is, I guess, 8. 8 is the answer. Will you proceed? 15th question. Fx is a fifth order polynomial like fifth degree with every x with every root of fx equal to 0 is real and distinct. Find the number of real roots of this. In question, the answer is 0. Yes, tell me, have you done it? Shall I do it? Okay. Fifth order polynomial, you can observe or you can make it on your own. Like this. K times all are real roots and distinct. So make them like this. Not known to us, but we make it like this. So we want to go till derivative and f dash x whole square. So first of all, we need to move on to that derivative and double derivative. Take log first on both the sides because derivative would become easy at that moment. So ln of fx is nothing but k times or ln k plus ln x minus x1 ln x minus x2 up to ln x minus x5. Then let's do the derivative of it. 1 by fx into f dash x is equal to then what do you do? One more time, because we want second derivative. One more time it should be differentiated. It applies the quotient rule in this case. So applying quotient rule, we'll get f dash becomes f double dash x multiplied by fx minus f dash x whole square. You understand the quotient rule? And this is whole square. Makes out to be derivative of this minus 1 over x minus x1 whole square. Clear? Everyone is going to be your negative times something whole square, as you can see. All are becoming negative. Make it in the bracket and make it negative. So makes this thing is always positive. So this expression is always going to be a negative expression. Can never be 0. You understand?